Okay, this is for section 3.1, and I'm actually going to split this up, and it should be some review of what you did in Algebra 1. The first part that we're going to do is solving systems of equations, where two equations, two unknowns, we're going to solve by graphing. And am I right? You did that in Algebra 1? Where you graph lines? Okay. And then we're going to do the next day, then we're going to do the substitution, the linear combination or elimination method. We'll go back and review those. This chapter will take you through the two equations, two unknowns, and then we're going to extend it to three equations, three unknowns, okay? And multiple methods of solving them. Okay, so on this first one, I'm going to go through a couple of examples. They will ask you to solve a system of equations by completing a table. Now, you guys can also do solve this system of equations by slope-intercept form of graphing. You can do that too. But I think there's one on tomorrow's, at least one on tomorrow's homework, where the y-intercept is not anywhere close to being on the graph. So a table is a good idea. And remember, I showed you how you can create a table on the calculator. You can do that too. Okay, so let's look at two equations. Let's say they do x plus y equals 3 and negative 2x plus y equals a negative 6. Negative 2x plus y equals a negative 6. And I'm going to actually put, in this example, I'm going to put the tables together. So basically you can choose any value for x, substitute it in, and solve for y. In this first equation, y equals, I'm going to get it in the form y equals mx plus b. So if I took this and got y by itself, y would equal a negative x plus 3. And then on this one, if I get it in y equals mx plus b, if I get this by itself, I'd have y equals 2x minus 6. So get them in the right form, and then sub in. So say x is 0. So if you put 0 into this one, you'd have a negative 0 plus 3, y would be 3. If you put 0, 2 times 0 is 0, 0 minus 6 is negative 6. Okay, and you can start graphing. One of the lines would be 0, 3, 0 to the right, and up 3. The other one, 0, negative 6. You do have to keep your lines separate. Okay, and then if we put in, like, if x is 1, so you'd have negative 1 plus 3 would be 2. If you put 1 in here, you'd have 2 times 1 would be 2, minus 6 would be negative 4. So one ordered pair would be 1, 2. So 1 to the right and up 2. And this one would be 1 to the right and down 4. So you can start seeing your lines. 2 points determine a line. All the rest of them will be checkpoints. And then if you put in 2, that'd be negative 2 plus 3 would be 1. And 2 times 2 would be 4, minus 6 would be a negative 2. So one ordered pair would be 2, 1, 2 to the right and up 1. So now we've got 3 points on that line. And then 2, negative 2, 2 to the right and down 2. So you can kind of see the two lines starting to come together. And then 3, if you put x as 3, negative 3 plus 3 would give you 0. And 2 times 3 would be 6, minus 6 would give you 0. So that's where your lines are going to cross at 3, 0. So basically, you can kind of sketch in. You don't have to, and just see where it intersects by making a table. The general rule on graphing is we like to do it by slope-intercept form, but if all else fails and you can't get a point on your graph, you can always go make a table of ordered pairs. So the point where these two lines intersect is 3 to the right, and that's 0. So solve that point satisfies both equations. Okay. Any questions on that one? Okay. And you can do those as separate tables. If putting them together messes you up, you can do it that way too. Okay. Okay. The next one. Let's say they ask you to solve, and this one they just ask you to solve the system. And you know, we're doing 2 equations, 2 unknowns. I said we're going to build up to 3 equations, 3 unknowns. I mean, for a lot of things like they do in the space program, they might be solving 20 equations, 20 unknowns. I mean, it can get more complicated than what we're doing. We're just barely getting in. This is solve the system of equations. By graphing. So not necessarily making a table of ordered pairs, but by graphing. So one equation is x minus 2y equals 0. The other equation is x plus y equals 6. For both of those, I would get it in slope-intercept form, y equals mx plus b. So on this one, I can get y by itself, y equals, subtract x, I'd have negative x plus 6, and then graph that. It's in the form y equals mx plus b. So it's going to cross at positive 6, so go up 1, 2, 3, 4, 5, 6. And the slope is negative 1. That's like negative 1 over 1. That's rise over run. And this is where some of you made the error. If it's a negative slope, you know which way it's got to tilt. So you can go down 1 to the right 1, down 1 to the right 1. You can do that enough that you get your line. Or you can go up 1, left 1, up 1, left 1. Enough that you can get your line. And a little... That's close doing it on this. Okay, and then on this one, solve if you added 2y and then divide by 2. So you get 1/2 x equals y. And that's in the form y equals mx plus b. So it's actually plus 0. So it's going to go through the origin. And always do the slope rise over run. So this is the rise over the run. So from that point, we're going to go up 1 to the right 2, up 1 to the right 2, and you should see a point at 4, 2 where it intersects. Okay, and you have the straight edges where you can. Okay, and then so it's going to intersect at 4, 2. 4, 2 would be your ordered pair. Okay. Everybody okay on that graph? So you can graph these by making a table of ordered pairs, okay, either by hand or on your calculator, and then you can use slope-intercept form. Okay. Okay. A couple of special cases I want to go through, and then some terminology we need. Okay. On this next one, same thing. We're going to say solve by graphing. And one equation is y equals 2x plus 5. And the other equation is y equals 2x minus 4. And notice they're already in slope-intercept form. So if you look at these, they have different y-intercepts, but the slope's the same. Without graphing them, what kind of lines are they? They're parallel, right? Because they go through at positive 5, and the slope is 2. That's like 2 over 1. So go up 2 to the right 1, up 2, right 1. Or you can go down 2, left 1. Enough that you get your line. I wish I had a straight edge on this. it'll do lines. It'll do straight. I don't know if it'll do straight lines if they're on a curve. Let me look. Line shape 2. Nope, won't do it. Has to be a horizontal line. Okay. Okay. And then the other one would go through at -4. And slope is still 2/1. Oop, sorry, got a point off. Go up 2, right 1, up 2, right 1. That look better. Okay, so when you graph these should be, it's a special case where they are parallel lines. They have the same slope, different y-intercepts. So as soon as you know they are the same slope, different y-intercepts, they cross the y-axis in different points, then they have to be parallel lines. Okay? What's the solution to the two equations? Is there any point in common? No. So this one would be no solution. No solution. Some authors will say no solution. Some authors will say the empty set. Okay? I think yours probably says no solution. Okay? Okay. Last special case, and then I want to go through some terminology. Okay, this is number 4. Same thing, they will just say solve by graphing. And let's say they give you -3x plus y equals 2, and a -6x plus 2y equals 4. Now look at those two equations. What do you notice? Yeah, they're the same equation because the second one is a multiple of 2. Yeah, multiply each term by 2. So it's going to graph the same equation. So basically, you need to take this one and graph it, get y by itself. So add 3x plus 2. So it's going to go through at +2. Okay, and the slope, rise over run, 3/1. So from that point, go up 3 and to the right 1, go up 3 to the right 1, or you can go down 3, left 1. And just remember, anything that tilts in that direction has a positive slope. Some of that, if some of you would have checked that on your test, that would have helped. Okay, this should be erased right there. Erase that. Okay, so on this one, these are coinciding lines. One line lies right on top of the other one. Okay, they are